This lesson is over graphing polynomial functions. Graph of a polynomial function. If p of x has a degree of n, then the graph has at most n real zeros, also known as x-intercepts, and the graph has at most n minus 1 turning points, also known as max or mins. Let's look at the following. Given the graph y equals x, we are going to identify the following. The type is that this is of the form y equals x. We're being asked to identify the degree, number of zeros, and number of turning points. So looking at the equation, we need to identify the degree, or the highest exponent. For x, since we do not see an exponent, it's understood to be an imaginary 1. Now if I go back and read the statement at the top, if a polynomial has a degree of 1, then the graph has at most 1 real zero, or 1 x-intercept. So look at the graph. Notice it does cross the x-intercept at one location. Now let's go back at the top again. If a polynomial has a degree of 1, then the graph has at most 1 minus 1 turning points. Well, 1 minus 1 is 0, which means if we look at the graph, it never changed directions. It remained the same direction the entire time. Let's look at another graph. This time we're looking at the graph of y equals x squared. Let's identify the degree. In this case, the degree is a 2. Again, we return to the top. If a polynomial has a degree of 2, then graph has at most 2 real zeros, or 2 x-intercepts, as we can see on the graph. Again, if a polynomial has a degree of 2, then the graph has at most 2 minus 1 turning points. Well, what's 2 minus 1? Well, that's 1. And looking at the graph, we see it changes directions at one location. Now let's look at the graph of y equals x to the third. Identify the degree, which we clearly see would be a 3. If a polynomial has a degree of 3, then the graph has at most 3 real zeros, or 3 x-intercepts. Again, we see that in the graph. If a polynomial has a degree of 3, then the graph has at most 3 minus 1 turning points. Well, 3 minus 1 is 2. And we see we do have 2 turning points, one max and one min. Let's look at another one. This is of the form y equals x to the fourth. If we find the degree, we will notice it is 4. If a polynomial has a degree of 4, then the graph has at most 4 real zeros, or 4 x-intercepts. If a polynomial has a degree of 4, then the graph has at most 4 minus 1 turning points. Well, 4 minus 1 gives us 3. And if we look at the graph, we see we have a max and a min, and a total of 3 of them. Now, the other thing you need to pay attention is it says at most n real zeros and at most n minus 1 turning points. The phrase at most does not mean guaranteed every time. It just means that's the most possible times it could happen. Now let's look at some steps for graphing polynomial functions. The first step, we need to determine the end behaviors, and we do that by identifying the leading term. Step 2, we find the zeros, which means we're actually finding our x-intercepts. Step 3, we do interval testing, and we will use a calculator to help with the calculations. This is the new step we have not covered before. Step 4, we find the y-intercept. Step 5, create a t-chart. Step 6, we graph. And finally, step 7, we check all the characteristics. Let's look at our first example. Example 1, graph the function h of x equals negative 2x to the fourth plus 3x to the third. First, I want you to look at the notation. Because it says h of x, that means this is a function. And anytime you have a function, it means it automatically will pass the vertical line test. The other thing I want you to look at the function is the domain. Do you see any fractions? Do you see any radicals? Since the answer is no, then that means we have nothing to be concerned about, so our domain is negative infinity to positive infinity. Let's look at the end behaviors. So first we identify the leading term, which in this case is negative 2x to the fourth. Since it has an even degree, that means that the arrows are going the same direction. Next we look at the sign. Since it's a negative, there will be a reflection across the x-axis. So in the end, in this case, our end behavior will be facing down on the left side and down on the right side. Now to find the zeros. Anytime you're finding the zero, you set your function equal to 0. So we have 0 equals negative 2x to the fourth plus 3x cubed. My leading term of negative 2x to the fourth is negative. To make that positive, what I'm choosing to do is to move all my terms from the right side of the equation to the left. When I do that, that now gives me 2x to the fourth minus 3x cubed equals 0. From here, I notice both terms have x's, so I'm choosing to factor out x to the third, which leaves me with 2x minus 3. Since these are two values multiplying to give you 0, I'm going to take each piece and set it equal to 0. The first piece is x cubed, so I set x cubed equals to 0. Next, I take the other piece, 2x minus 3, and set it equal to 0. And now I'm ready to solve. The first equation of x cubed equals 0. Well, what number times itself 3 times could give me 0? Well, that would have to be x equals 0. For the other equation to solve for x, we would need to add 3 to both sides, and then divide both sides by 2, and we find x equals 3/2. So we have found the solutions, but remember, we're trying to find the zeros or x-intercepts, which means we must write these as ordered pairs. My first solution of x equals 0, to be rewritten as an ordered pair, would be 0, 0. Now, I do want to identify the characteristic, meaning is this tangent or will it cross? To identify, I have to go back to the factored form to identify its multiplicity. Notice in the factored form, this was written as x to the third. Well, x to the third means x times x times x, which means it was repeated 3 times. Since 3 is odd, that tells me it will cross the x-axis at that intercept. Now the other 0 is x equals 3/2, but again, we must write that as an ordered pair, which would simply be 3/2, 0. Again, I want to identify its characteristic, so I go back to the factored form to look at its multiplicity. Since I do not see an exponent, That means there's an understood 1 there. Since 1 is odd, that means it too will cross the x-axis at that location. So our zeros are 0, 0, and 3/2, 0. Now let's try interval testing. Interval testing is the new part we have not encountered before. So to do interval testing, we draw a number line, and we put the marks along the number line for as many zeros as we encountered. Notice previously we found 2 zeros. We found x equals 0 and x equals 3/2. Since we have 2 of them, we place 2 marks on the number line. And then we put the numbers in the correct sequential order. 0 comes before 3/2. Now what these numbers do is they divide the x-axis into different sections, which means I have a left section, a middle section, and a right section. And so what we're going to do is we are going to choose numbers or values from each section. So I need to pick any number that's to the left of 0. The most common number people think would be -1. Now I need to choose a value between 0 and 3/2. Well, remember, 3/2 is 1.5. And so an easy number between 0 and 1.5 is 1. And then for the right region, I need to choose a value that is larger than 1.5, and that would be 2. And so what we have just found are our test values. Basically, it means we chose random values for x. Now we're going to use those values of x to find the result or the output or the function value. So take some time now to substitute a -1 into the function and see what you get as a result. Hopefully you found the result to be -5, which means when I put the information together, I can now write it as an ordered pair as -1, -5. Now because when I plugged in a -1, my result was a -5. That means if you were graphing, would your point be above or below the x-axis? Well, since it's a -5, that means it will be below the x-axis, which means your graph will be going down below the x-axis. So I draw a small sketch along my number line as a visual reminder. Now in the middle region, we chose x to equal 1. I need to find the corresponding y value. Take the time now to plug a 1 into the function. Hopefully you found the result to be 1, which means the corresponding point would be 1, 1. Since I plugged a 1 into the function and I got a +1 as a result, if I were to plot that point, would it be above or below the x-axis? Since it was a +1, it will be above, which means my graph will be above the x-axis. So I draw a little sketch above my x-axis indicating that between the two x-intercepts, my graph will be above the x-axis. Now for the right region, we have an x value of 2. Take the time now to plug that into the function and let's see what you find. Hopefully you found the corresponding value to be -8, which means the point would be 2, -8. Since the result was a -8, it means graphically I would be going down below the x-axis. And since it's below, it means my graph will also be below the x-axis. Now we're moving on to the next step, which is to find the y-intercept. Now remember, y-intercept simply means where x equals 0. So looking at the function, you plug a 0 in for x, and we see 0 to the 4th is 0, 0 cubed is 0, and so what we're left with is y equals 0. So in this case, we have found our y-intercept, but it must be written as a point which would simply be 0, 0. Now we're ready to do our t-chart. So go ahead and prepare your t-chart. And where we are going to collect most of our points is from the interval testing. Now we read our interval testing from left to right. The first point we found was -1, -5. The next point is actually going to be your x-intercept, that divider, which is the point 0, 0. Looking back at your interval testing, the middle region is represented by the point 1, 1. Next, we encounter another x-intercept, which is 3/2, 0. And then the right region is represented as 2, -8. So all of these points came from the interval testing. Now let's look back at our x-intercepts, our zeros. Are those values already included in our t-chart? Yes. Now we look for our y-intercept. Is that already included in our t-chart? Yes. The last thing is we look at the t-chart and see if we have any gaps or missing numbers in our numbering. Well, -1, 0, 1, 1.5, 2. There appears to be no missing values, so our t-chart is complete, which means we're ready for the next step. Let's graph. To graph, we are going to need our xy axis, so take a moment now to prepare that. All right, now we're ready to plot these points. The first point is -1, -5. Then we have 0, 0, 1, 1. 3/2, 0 simply means 1.5, 0. And then 2, -8. So we have this collection of points, but to connect them, we do it in order. So it goes from the point -1, -5 is then connected to 0, 0, which is then connected to 1, 1, and so on. So we graph them from left to right. Now that we have the graph, we're ready to check the characteristics. By characteristics, the first one is we check the end behaviors, which was step 1. We said our graph was going to be downward facing on the left and downward facing on the right. Does our graph do that? Yes. Next, we check our multiplicities. We said at the intercept 0, 0, it would cross the x-axis. Does ours cross? Yes. We also said at the x-intercept of 3/2, 0 that it would cross. Notice our graph also confirms that. Next, it says at most n number of zeros. We said we had a degree of 4, which meant we had at most 4 zeros. How many times does our graph cross the x-axis? It only crosses it twice, but is 2 less than 4? Yes, which means we are okay. The last one is at most there's n-1 turning points. Well, our degree was a 4, which means at most 4 minus 1 turning points. Well, 4 minus 1 is 3. Ours appears to only have 1 turning point, which is less than 3, so we are okay. So that is your official graph. Example number 2, it says graph. We have g of x equals -x to the third plus 2x squared plus 4x minus 8. We know this is a function because we see function notation, and we want to identify the domain. Now notice there's no fractions, no radicals, which means the domain is all real numbers or -infinity to +infinity. So let's start with our end behavior. We identify the leading term as -x to the third. Since it's an odd degree, that means the ends are going opposite directions. Next, we look at the sign. Since it's negative, it will flip across the x-axis, which means on the left side of the graph will be going up, the right side of the graph will be going down. Now to find the zeros, that's where you take the function and set it equal to 0. So 0 equals negative x to the third plus 2x squared plus 4x minus 8. Since my leading term is negative, I want it to be positive, so I'm going to move everything from the right side of the equation to the left side. So I'm now looking at x to the third minus 2x squared minus 4x plus 8 equals 0. Since I have 4 terms, I will do factor by grouping. I look at the first 2 terms. I look at the last 2 terms. Now looking overall at the problem, I see that there is an x minus 2 that is in common. So I have factored it, but not both pieces are linear. Notice I have x squared minus 4. That is the pattern of difference of squares, so that can factor into x plus 2 and x minus 2, and I still have the x minus 2 as well. Since I have some number times some number times some number equals 0, I'm doing pretty good. But look at your factors. Are anything repeated? Yes. Notice x minus 2 is listed twice, which means I can rewrite this. I can rewrite this as x plus 2 times x minus 2 quantity squared equals 0. So I still have some number times some number equals 0, which means we still set each piece equal to 0, and we solve. So the first 0 is negative 2, the other 0 is x equals 2. Now remember, we're not looking for solutions, we're looking for the x-intercepts, so these must be written as points. The first one would be written as negative 2, 0. Now, let's look at its multiplicity. How many times did this 0 appear? So looking at the factored form, notice we see no exponent, which means it's raised to a power of 1. Since 1 is odd, this crosses the x-axis. Now we look at the other 0 of x equals 2. We need to write that as a point, so that'd be 2, 0. Now look back at its multiplicity. Since the factor is raised to a power of 2, which is even, that means this will be tangent. So our zeros are t for tangent. It'll be tangent at 2, 0, and it'll cross c at negative 2, 0. Now we're ready for our interval testing. Since we found 2 different zeros, we're going to have 2 marks along our x-axis. And our values are negative 2 and 2, and they must be in the correct order as they would appear on the number line. We go ahead and draw our lines to divide our different sections. Now in this case, I have 3 sections, and so I choose a number that is to the left of negative 2, probably thinking of negative 3. Next, I choose a value between negative 2 and 2, which may be 0. To the right of 2, we choose a value of 3. And so since we have chosen our test values, or x values, it's now time to find the corresponding y value. Go ahead and take the time now to find the corresponding y values for each of those regions. Okay, when x equals negative 3, hopefully you found y to be 25, which means the corresponding point is negative 3, 25. Since 25 is positive, it means it would be above the x-axis, which means our graph would also be above the x-axis as well. For the value of 0, we found the corresponding y value to be negative 8, so the point would be 0, -8. Since it's negative, we would be below the x-axis, which means our graph would also be below the x-axis. For the right region, we plug in a 3. The result is a -5. So the ordered pair is 3, -5. Since it's -5, that means it will be below the x-axis, so our graph will be below. So the number line gives you a brief sketch or a rough outlook as to the shape of the graph. To find the y-intercept simply means to substitute a 0 in for x. And so we have y equals 0 to the third plus 2 times 0 squared plus 4 times 0 minus 8. Well, 0 cubed and 0 squared and 4 times 0, well, all of those give you zeros, which means the only value that remains is the constant, which is y equals -8. Now, remember, the y-intercept is a point, and it must be written as such. So your y-intercept is 0, -8. Now we're ready for our t-chart. So we're going to gather our points from our interval testing. Our first point is -325. Then comes our x-intercept of -2, 0. The point from the middle region is 0, -8. Then we have our next x-intercept of 2, 0. And then we have our right region of 3, -5. Now from our t-chart, we have a good collection of points, but I want to make sure, did I include my zeros? Yes. Did I include my y-intercept? Yes. Now we look at the t-chart and we see, do we have any gaps or missing numbers? And we do. We go from -3 to -2, and then we jump to 0. Well, the number that's missing is -1. So we do need to take the time to find these additional values. You need to find where x equals -1 and where x equals +1. Take the time now to do that. Hopefully you found -1, -9 and 1, -3. Since our t-chart is complete, let's graph. Go ahead and prepare your XY axis. And now take the time to plot the points. Once you have plotted your points, you do graph them in the correct sequential order of the t-chart. Now, out of all the points, most of them were manageable. The one that was a little large was the -325. So that point does not need to be included on your graph, but the fact that it's -3, +25 tells you the direction of where your graph is coming from. So now that we see our graph, we're ready to check the characteristics. First characteristic is check the end behaviors. We said it was going to be going up on the left side and down on the right side. Our graph seems to be doing that as well. Next, we check the multiplicities. We said at the point 2, 0, it was going to be tangent. And notice it does. It hits the x-axis and bounces right back that same direction. We said it was going to cross at the point -2, 0, and from our graph, it appears it does that as well. Next, it says you're going to have at most n zeros. Since our degree was 3, it meant we were going to have at most 3 zeros. Well, we did have 3 zeros. It just happens to be that one of them repeated. And next, at most n-1 turning points. Since our degree was 3, 3 minus 1 means we would have at most 2 turning points. Well, looking at your graph, you have 1 min and 1 max, so it appears to be true.